Hello students, welcome back to the fourth lecture on classification and tabulation. In the previous class, we have studied the examples on formation of discrete frequency distribution. Today, we will start formation of continuous frequency distribution. Here, suitable class intervals are formed on the basis of the magnitude of the data or the size of the data. For each value, a tally mark is marked against the class in which it falls. This process is continued until all the values are exhausted. The tallies of each class are counted and written as frequency of that class. To construct a continuous frequency distribution table, it is essential to know the following factors. First factor we have to study here is range. It is the difference between highest and lowest value in the data. That is range, which is denoted by R, which is equal to HV minus LV, that is highest value minus lowest value. Range R is equal to highest value minus lowest value or least value. The next point is class. The sub range is called class. If the range is vast, then it is divided into subclasses, that is called as sub range, and sub range is nothing but class. Then the next definition is class limits. The lower and highest values which are taken to define the boundaries of the class are called class limits. The lowest value is called lower limit LL, and the highest value is upper limit, that is UL. For example, in the class interval 10 to 20, 20 to 30, these are the class intervals where 10, this 20, 20, 30 are nothing but class limits. Next definition is inclusive class. In a class, if lower as well as upper limits are included in the same class, such a class is called inclusive class. Here, upper limit of a class is not equal to the lower limit of the next class. For example, the class interval 0 to 9, 10 to 19, 20 to 29, these are nothing but inclusive classes. Here, the limits 0 and 9 is included in the same class interval 0 to 9, or the limit here 10 and 19, which are included in the class interval 10 to 19. So these are the inclusive classes. Then the next definition is exclusive class. In a class, if the lower limit is included in the same class and upper limit is excluded from that class but which is included in the next class, such a class is called exclusive class. For example, the class interval 10 to 20, 20 to 30, 30 to 40 and so on are exclusive classes. Here, you consider the first class interval 10 to 20. Here, 10 is included in this 10 to 20 class interval, but 20 is excluded from this class interval and which is included in the next class interval, that is 20 to 30. Or in the second class interval 20 to 30, here 20 is included in this 20 to 30, but this 30 is excluded from this class and which is included in the next class interval, that is 30 to 40 and so on. So these are exclusive class intervals. Then the next point is correction factor. Correction factor is half of the difference between lower limit of a class and upper limit of the preceding class or previous class. Correction factor is half of the difference between lower limit of a class and upper limit of the preceding class or previous class. That is, correction factor is equal to lower limit of a class minus upper limit of previous class divided by 2. Now to get exclusive class intervals from inclusive class intervals, we have to add correction factor to all upper limits and subtract the correction factor from all the lower limits. First we have to calculate the correction factor, and that correction factor we have to add to all the upper limits of the inclusive class intervals, and it should be subtracted from the all lower limits of the inclusive classes. Then resulting class intervals you will get the exclusive class intervals. Then the next definition is open-end classes. In a class, if the lower or upper limit of the class is not specified, such a class is called open-end class. Means there is no end. That is called as open-end class. For example, less than or below 10. Less than or below 10. Here, the lower limit is not specified. Less than 10. Less than 10 means 9, 8, 7, 6, 0, minus 10, minus 20, minus 30 and so on. There is no lower limit. So this is the open-end class. Or more than or above 70. Here the upper limit is not specified. More than or above 70 means it is 71, 75, 80, 90, 100, 120, 1000 and so on. The upper limit is not specified. So such class intervals are called as open-end classes. Then the next definition is midpoint or class mark. The central value of a class is called midpoint or class mark. The central value of a class is called midpoint or class mark. It is the average of class limits. It is the average of class limits. Here the midpoint or class mark is denoted by m or x, and it can be calculated as m or x equal to lower limit plus upper limit divided by 2. Lower limit of a class interval plus upper limit of that class interval divided by 2. For example, midpoint of the class 10 to 20 is m equal to 10 plus 20 divided by 2. So 10 plus 20 is 30 and 30 divided by 2 is 15. So the midpoint of the class interval 10 to 20 is 15 and so on. Then we have the next definition, class width or class size. Width or size of the class. The difference between the upper and lower limits of a class is called width of the class or size of the class, and it is denoted by C or I or W. The class width or class size is denoted by C or I or W. For example, the width of the class interval 20 to 30 is C is equal to 30 minus 20. 30 minus 20 is 10. It is nothing but upper limit minus lower limit. Upper limit is 30 minus lower limit is 20. So 30 minus 20 is 10. This is nothing but class width of the class interval 20 to 30. We have to note here, in case of inclusive classes, width of the class interval has to be calculated after converting the inclusive classes into exclusive classes. And we have seen that how to convert inclusive classes into exclusive classes. When we need to calculate width of the inclusive classes, first we have to convert the inclusive class into the exclusive class, and then as usual we have to find width of the class. Then the next definition is number of classes. The number of classes can be obtained by using the Professor Sturge rule, and that is number of classes k, which is equal to 1 plus 3.322 into log n. Number of classes k equal to 1 plus 3.322 into log n, where n is nothing but number of observations. Here width of the class C is equal to range divided by number of classes. Width of the class C equal to range divided by number of classes. So in the next class we will study some more definitions and we will solve the examples on formation of continuous frequency distribution. Meanwhile, you read and remember all these definitions which are very very important for the exams. Thank you.